Welcome to Tolleson Physics. So what we're going to work on today is the difference between static and kinetic friction and how to figure out what those numbers mean when you use those coefficients and how to apply to a simple block system. And so what we're going to look at first is we're going to look at a block on just on a rough surface, and basically on this rough surface we're gonna apply a force to the block, and the coefficient of static friction is 0.2 in this case, and the coefficient of kinetic friction is 0.1. So the coefficient of static friction is always larger, or it can be equal to, but it's larger than the kinetic friction because it's harder to get something to start to move. And so what we're going to look at is what happens when we apply different forces to this. And so we're going to start off really simply where we're going to apply a push force of 1 Newton. All right. So when we apply 1 Newton of force, this thing's not going to move, right? So if we think about a force diagram, right, we've got the force due to gravity, we've got the normal force. We know that those are going to be equal because it's not accelerating in that direction. And then what I'm going to have is I'm going to have my push force, which I said is 1 Newton, and I'm going to have a frictional force that's holding it back. And I made the claim that it's not going to move. And so these two arrows have to be the same size, and so that force of friction is 1 Newton as well. Now, of course, we can calculate the force due to gravity. That's mass times the acceleration of Earth's gravity, and when we use 10 for that, this ends up being 100 newtons. And then since we said the normal force is the same magnitude as the gravitational force because it's not accelerating in that direction, then that is also 100 newtons. All right, so the question then becomes, well, how much force would I need to push to be able to get this to move? And so that's where the coefficient of friction is going to come into play. What we're going to do is we're going to use this idea where essentially you can calculate the maximum force of friction if you multiply the coefficient of friction times the normal force. All right, and so the force of friction can't exceed this value. So that means once I get to that value, this block will start to accelerate. And so let's figure out what that force would be. 1 Newton I claim was not enough. And so let's substitute in 0.2 for the coefficient of friction, and the normal force I've calculated conveniently over there as 100 newtons. So my force of friction max is going to equal 20 newtons. All right, so I need to push this with a force of 20 newtons. So what happens when I push with 10 newtons of force? Well, the force of friction is 10 newtons. When I push with 15 newtons of force, the force of friction is 15 newtons. It doesn't move. When I push with 19.9 newtons of force, the force of friction is 19.9. It doesn't move. Once I hit 20, just barely exceed 20, then this will start to move and it will start to slide, and it's going to change my situation a little bit. And it's going to change because now once it starts moving, the kinetic force of friction comes into play. So it's harder to get it to move. So once it gets moving, so let's say that now I went all the way up to 20 newtons and that caused it to start moving. What's my new force diagram going to look like? Well, my force due to gravity doesn't change because it's the same mass and I'm still on Earth. Therefore, the normal force doesn't change. 100, right? Up equals down. Now I'm saying that, okay, once I got just slightly larger than 20 newtons, but I'll round it to 20 newtons, it started to accelerate, which means my force of friction arrow is no longer 20 newtons when it was static. So let's calculate now that it is kinetic. So I'm going to use the kinetic force, or this is technically the static force of friction, and actually we'll leave the max out. So it's still the same equation. It's the coefficient of friction times the normal force. But now the coefficient of friction dropped. It's 0.1. The normal force didn't change. And so since the normal force didn't change, 100 times 0.1, that equals 10 newtons. So now my force of friction is 10 newtons. So I could actually calculate what's the acceleration. Well, acceleration is based on Newton's second law. So the net force divided by the mass. What's the net force in this case? It's going to be in the direction of acceleration. So F push minus FF, force of friction. So 20 minus 10 equals 10 newtons. And what's my mass? It's 10 kilograms. And so the acceleration in this case is 1 Newton per kilogram. All right. So the take-home message, right? So there are a couple take-home messages here. Is the coefficient of friction can be different between static and kinetic, but the coefficient of static friction is always greater than the coefficient of kinetic friction. It's harder to get something to start moving. Once it's moving, it's kind of gliding on top of those tiny microscopic surfaces. The van der Waals interactions are much less, and so it can slide much easier. And we can use, if we know the normal force, we know the coefficient of friction, we can calculate what that maximum amount of friction is. And realize it's the maximum amount of friction. When that thing's not moving, if you push with 1 Newton of force, it pushes back with 1 Newton of force. If you push with 10 newtons of force in this example, the force of friction pushed back with 10 newtons. It wasn't until you got to the maximum value that it would start to slide and accelerate.